How does the discriminant lead to imaginary numbers? Imagine solving a quadratic equation and hitting a wall where you can't find real solutions. That's when the discriminant plays a surprising role. It's a small part of the quadratic formula but holds big clues about the solutions. The discriminant is the part under the square root sign, written as B2 for AC. Here, A, B, and C are the numbers in your quadratic equation. This value tells us whether the solutions are real or not. If the discriminant is positive, you get two different real solutions. If it's 0, there's just one real solution, called a repeated root. But if the discriminant is negative, things get interesting. You won't find any real solutions because you can't take the square root of a negative number in the real number system. That's where imaginary numbers come into play. To handle square roots of negative numbers, mathematicians use the imaginary unit, which is written as I, and is defined as the square root of -1. So, when the discriminant is negative, you rewrite the square root of that negative number as a multiple of I. For example, if the discriminant is -9, then the square root of -9 becomes the square root of 9 times the square root of -1, which simplifies to 3 times I. When you plug this into the quadratic formula, the solutions involve I. They look like this. X is equal to plus frac B plus PMI plus SQRT, B2 4AC2A. These solutions are called complex roots because they include both a real part and an imaginary part. They always come in pairs called conjugates, meaning one has a plus I and the other a minus I. Knowing the discriminant helps you quickly see if your quadratic will have real solutions or if you'll need to work with imaginary numbers. This is especially useful when graphing quadratic functions. If the solutions are real, the parabola crosses the x-axis. If they are imaginary, the parabola stays above or below the x-axis and doesn't touch it at all. So, in simple terms, the discriminant leads to imaginary numbers when it's less than 0, showing us that the solutions are not real but involve the imaginary unit, I. This connection makes solving quadratic equations more straightforward and helps us understand the shape of the graph better.